Hello, I'm Renée Fleming. Welcome to Music and Mind Live. This week's episode is Mind Games, New Tech for Music and Health. And I'll be welcoming three brilliant guests, each one a polymath, as we discuss the future of music, health, and technology. Dr. Adam Gazzaley is the David Dolby Distinguished Professor of Neurology, Physiology, and Psychiatry at the University of California, San Francisco, and founder and executive director of Neuroscape, a center devoted to brain research and the creation of new technology. He will discuss his work that uses digital medicine and therapeutic video games to treat ADHD and other conditions. Composer Tod Machover, called a musical visionary by the New York Times and America's most wired composer by the LA Times, is the professor of music and media at the MIT Media Lab, where he also directs the Opera of the Future group. Tod will talk about his composition, stretching the boundaries of music technology, as well as some of the groundbreaking research from the MIT lab. And finally, Dr. Grace Leslie, who directs the Brain Music Lab at Georgia Tech's Center for Music Technology. A flutist and electronic musician, she creates brain music tech that reveals the internal states of a performer's brain to an audience. Oh my, it's going to be a fascinating episode. Before we begin, a reminder to submit questions in the comment section on my Facebook page. Welcome, Adam, Tod, and Grace. Each of you have been at the forefront of research and innovation for digital medicine treatments in healthcare. So starting with Adam, can you tell us what is digital medicine and how does digital medicine fit into the larger goal of whole person and integrative health? We discussed this last week with Dr. Emmeline Edwards from the NIH.
Sure. So it's a big topic, and I won't cover it in all of its depth, but the basic idea is that digital technology can be used to transform medicine by its ability to capture data remotely with people in their own homes. So it has a diagnostic component to it, but it also has a therapeutic treatment component. So as everyone here appreciates, we've really relied on pills or molecules to treat us for many conditions, including those afflictions of the mind, anxiety and depression and other things that we suffer from. The idea that we can use digital technology to create experiences, I often even think of it as experiential medicine, is something that many people are excited about. Experience is the driving force of our brain's plasticity, which allows us to modify how we function and can improve our performance and our behavior. So whether we're suffering clinical conditions that need treatments, or we're trying to improve our ability to focus and make decisions, even empathy and compassion, all of that is part of the bigger field of using digital technology to help enhance us as humans. And that's something that I think we're all excited about, that's starting to emerge into the world now.
I think it's fascinating that you tout experience as the crucial piece of the puzzle, which is why I suppose when children are learning, when they can have some sort of motor activity involved with learning, they learn, it sticks better. Is that right?
Yeah, experience is as core to being human as anything. I mean, it's almost synonymous with mind and consciousness in a lot of ways. It's fundamental. It's how we grow and learn throughout our lives. We often thought that for a long time that experience drove brain plasticity, but it really stopped at some stage after development. And then we mostly degraded. And now we know that experience induced plasticity is something that the human brain is capable of through our entire lives. So the real question here is, how can we use technology in this way to create very personalized, powerful experiences that allow us to continue to improve our function no matter what we're faced with?
So pills might be outdated at some point. That's great.
Yeah, I think that we probably, they won't go away. I think that that's very unlikely, but I do feel that we have relied on them too unconditionally, too much as a silo. This idea, I like to talk about this of like a magic brain pill, something that we're going to find that's just going to fix it all, like one easy dose in the morning and no more Alzheimer's, no more autism, nothing, no depression. I think it's just something that's not going to happen. And we have to wrap our heads around other approaches that may work with pills to make them even more effective and allow us to decrease the doses so we can have less side effects.
Great. So we have a mutual friend, drummer Mickey Hart from the Grateful Dead. So I'm going to show a clip of him performing, as he's been on Music of Mind Live also back in July, but at the Kennedy Center, your virtual reality music and rhythm game, Coherence. He did a quite spectacular performance. We're just going to show a little of it.
Mickey's an artist, lots of extra flourishes. So each of those thunderclouds indicate a change of challenge, more rhythms.
See, it just looks like so much fun to me. I really want to play. So what is Coherence and how does it work?
Yeah, so Coherence is a game that we designed actually with Mickey's inspiration. We were teamed up to do a talk together for the AARP actually on Alzheimer's and music and its potential role. And we wound up becoming really close friends and worked on this project together. And the idea behind Coherence is something that has really been very near to Mickey's heart. And I know you know this, Renee, for decades, and that music is and rhythm is entertainment for sure, not denying that, but it holds so much more promise, this ability to really improve and elevate the function of our minds and our brains. And he has been telling that story for a long time. And what we tried to do with Coherence was to create a game that is fun to play. So it's medicine that tastes good. We developed that particular one, as you could see, in virtual reality. It's hard to capture that in a video because he's immersed in this beautiful 3D world. But the idea is that if you can engage in a rhythmic experience with enough depth, so not just sensorially, so you're hearing and seeing the rhythms, but you're also engaging your body movements in the rhythm, it will help the abilities of anticipation and timing, which are fundamental to rhythm, but are actually fundamental to how our entire brain works. So everything we do is sort of in anticipation of the future. And we know that these abilities decline with age, and they're impacted by many other conditions like dyslexia. And so the idea is that we can have you play a fun rhythm game, which to the player will feel very much like any other game. But the idea is that the rhythmic experience will be so adaptive and such a high level that will essentially fine tune the brain's rhythmic nature itself. And we'll see all these benefits in terms of cognition. And so the game is now built, and Mickey has been part of that team and many others. And now we're just beginning the research phase, both in adults and older adults and children with dyslexia, to see if we could deliver a digital medicine version of a rhythm game and have benefits that we've been unable to achieve in other areas.
Well, I'm looking forward to that myself. So your recent project is now the first FDA-cleared digital treatment for ADHD and the first video game approved by the FDA as a treatment for any medical condition. So this is very exciting. Congratulations. Tell us about EndeavorRX.
Yeah, so this has been a 12-year journey for me. It's not over, but we did have a big milestone, as you said, FDA clearance. We turned a video game into a medical device for the first time ever. And it's been a real wonderful but challenging journey. It's the basic idea that we've been talking about, that video game is really a deliverer of an experience, a fun experience, but our games are adaptive. And so they're constantly challenging an individual right to the limits of their ability. And what we showed with this game over the years was that playing the game improves your ability to play the game, but more interestingly and more importantly, it actually improves your attention abilities when tested from before to after. And our first paper on that was in Nature in 2013, where we showed that we can improve the attention abilities of older adults. And now, over the years, it's involved starting a company and doing multiple trials, including a phase 3 trial, which is sort of the highest level of trial you can do, double-blind, placebo-controlled, multi-site in children with ADHD. That study was run out of Duke by Scott Collins. And what we showed was that we can improve the ability of children with ADHD to sustain their attention on really boring tasks, things that they suffer from quite significantly beforehand. And so we presented that to the FDA for clearance as a class 2 medical device. Right now, as you know, the system is currently stimulants like Adderall to treat children with ADHD. And after years with the FDA, we now have approval to have a prescription video game that we're just about to go to market with. So doctors could write a prescription just like they would for any other drug, but in this case for a video game. And then a child will play this for 30 minutes a day, 5 days a week for a month, and have the improvements that we've shown in our study in their attention abilities.
So when I first heard about this too, I thought that's got to be paradoxical that a video game would help with ADHD or ADD. And yet it makes sense that if they can focus in that environment, which is highly stimulative, then they could probably focus otherwise. We're going to show a short trailer from the video game. Here it is, EndeavorRX.
We'll see if you're up to the task. Now get going. Only capture these little whippersnappers. You're getting it. Wonderful.
Wow. And what parent would not want a non-pharmaceutical aid with ADD and ADHD? Willie, well done. How did you develop the game though? As you, Todd, we're probably listening to the music, right? Who worked with you on this?
We had a very, very diverse team. So one of my fundamental design tenets had been from the beginning is to treat every aspect of development like with the highest integrity and reach the highest level. So sometimes you'll see a scientist like myself develop a video game, and it's barely a video game. It might have really good underlying principles, but it doesn't. It's not fun, and it doesn't really fulfill what players, especially children, expect from a game these days. And so we worked with like a very, very high level team, artists, musicians. One of our music leads won an Academy Award for, you could tell a little Star Wars theme there. We have a lot of Lucas Arts folks on our team. And so so we bring in all of those elements of reward and interactivity, fun, that allow this type of medicine to be really enjoyable to children that are engaged in it. But it took many years to build that game.
Yeah, kids are picky. So yeah, it's a good thing you did it that way. Thank you so much. We'll come back to you later, Adam. So Todd, you're an innovative and prolific composer, having written groundbreaking operas, one of which I saw in Monaco, which is fantastic, with live electronics and robotics, as well as works for virtuosi from Yo-Yo Ma to Prince. But you've also been at the forefront of new technologies for music. So tell us what the hyper instrument is and how it applies to performance in medicine.
Thanks, Renee. And that game's awesome, Adam. I'm going to go out and get that right after our session. So I've been interested in not just using technology in music, but in making technology as natural to musicians and the blend of technology and music as natural as possible for a long time. And the idea of hyper instruments is to have an instrument. It could be an instrument you already play. It could be a brand new instrument that we develop that naturally watches and listens to how you play and allows you to use musicianship you already have to augment and expand the instrument. So it knows about the sound. It knows about, for instance, a major hyper instrument that we designed was for Yo-Yo Ma. And so we had to build a cello from scratch. We actually, you know Yo-Yo very well, nicest guy in the world. When we talked about putting tape and glue on his Stradivarius, he didn't like that idea. So we built a special cello that had all the sensors inside, measured the sound, measured the vibration of the instrument, hand on the fingerboard, the movement of the bow on the cello. And all of this information is analyzed so that the slightest change of expression and nuance and where a phrase is going and which note is emphasized is understood by the instrument, so that just by changing your interpretation, a cello can turn into a whole orchestra, or it can turn into a voice, or turn into a sound you've never heard before. And so we've designed instruments like that for a long time. And actually, when I finished the instrument for Yo-Yo, and we learned a lot by doing this, I realized that if you could have a musician of that stature feel comfortable with an instrument like this and produce something interesting, you should be able to adapt the same technology for really anybody, for a student learning an instrument, for the general public. And in the case of, it was the first time that I thought that perhaps you could use technology like that to allow people to express themselves who maybe couldn't communicate so easily. So if we could bring up the slide, yeah. So this is somebody named Dan Elsey, who lives in a hospital in the Boston area. And Dan was born with cerebral palsy. So he has great difficulty controlling his movement. He can't speak. And I went to do a workshop at the hospital where he is. And actually, we had, at that time, software for people to compose their own music. Anybody could compose music. And I asked a room full of patients who'd be interested in using this software to compose your own music. The software is called Hyperscore. It uses lines and color. It's very simple to use, but really you can compose any kind of music. It's quite sophisticated. So I expected a few people in the room to say they were interested in trying this, but in fact, quite a few people in the room raised hands or moved their bodies, and Dan indicated that he was really interested. So he participated in the workshop. Nobody had ever asked him before if he was interested in music, if he wanted to make music, and it turned out that he loved music. And you might remember from the slide, the picture you just showed, he already had a very primitive device on his head where he could point and pick out letters, which turned into speech. So we made a better device for him so that he could use this software. He learned to use it really well, actually. He could draw the lines, make his music, and it turned out he was really talented, made some fantastic music. So we worked with him. He came into the media lab, started making better and better music. Turned out he was also quite an exuberant person. He had a lot he wanted to express. And so we said, would you like to perform your music? And he said, yeah. And so we made a better version of the head tracking device and used similar software to what we designed for Yo-Yo. So, if you can measure a bow, if you can measure a fingerboard, you can measure somebody's movement. Of course, the difference with somebody like Dan is that he couldn't control perfectly, exactly when his body would give a downbeat or give an articulation. So we had to make the software capable of learning during rehearsal what he intended, where a phrase was going, and then look at what he actually did to make a performance. So we did this. It turned out he was a fantastic performer as well. So we actually went out to the TED conference together in California, and he performed his piece using this special hyper instrument for Dan. And maybe we could take a quick look at that.
So first of all, it's so beautiful. You know, the sounds are beautiful, and I just find that incredibly moving. What an extraordinary gift for him to be able to express his creativity. So you also have your Opera of the Future group and the MIT Media Lab, and you've had so many innovations, including for the general public. Even Guitar Hero came out of your lab. Is that right?
That is right. It did.
That's really amazing. And I was fortunate to have the opportunity to
I'm not
visit
just
the MIT Media Lab.
the Guitar Hero actually, just like the work for Dan Elsey came out of this Cello for Yo-Yo, the line to Guitar Hero came out of that work also. You know, if you, it's funny, you start with building a sophisticated cello, make all the software, make all the hardware, and I think Grace and Adam probably know this too. You know, amazing things turn out of this work that you don't necessarily predict at the beginning. So the way to measure somebody playing a guitar in Guitar Hero is very similar and derived from, you know, what we did for Yo-Yo.
So what are some current projects in development?
So there's a whole line of work related to using music for therapeutic and health benefits of all kinds. And maybe if we call up that next slide, I have a PhD student right now named Alexandra Riguer. And was there a slide before that? Because I had her picture. Maybe I took that out by mistake. Anyway, Alexandra's amazing. She came to the Media Lab with a degree in neuroscience and music from Stanford, and then she'd gone to Dartmouth to do a first master's degree, went to Oxford in between. And she's one of those people who has a deep understanding of music and a performance experience, but is an amazing neuroscientist. And she's been designing what she calls meta-musical instruments, which are instruments, first of all, that use a lot of things that we know about from music, like fine motor control and listening carefully, ability to touch and feel things tactily with great precision, to apply them to medical devices, so to improve medical devices in general, and then to create devices that are beneficial for people, like for Dan, but even in more and more targeted ways. So if we pull up the next slide, one of her recent devices is something called the LabraSense. Maybe that's the slide you just showed. And this is something, yeah, there it is. So this is a device designed for people who have difficulty with movement, maybe a stroke, or some people who've suffered with COVID-19 have difficulty with fine motor control. So this is a labyrinth that gives sensory feedback designed to recover fine motor connectivity. And the idea is to trace your finger in that wiggly area. It makes more pleasant sounds, the more you're staying inside the trajectory and not bumping up to the edges, and the more you're moving smoothly. It makes kind of nasty sounds, the more irregular your movement is. And it's beautiful, interesting to use. So just as the kind of games that Adam described, it's motivating. People enjoy using this system more than any other similar system that we've seen. And
Can we hear it?
yeah, let's hear just a tiny bit of it.
It's lovely. Harp.
Yeah, it's harp. So anyway, Alexandra's been working more and more with Mass General Hospital, Department of Neurology. The plan right now is to make a whole series of these, probably about 100 of them, to get them to patients. Another advantage of this kind of instrument is that it sends out precise data about how somebody is progressing. And so it's perfect for telehealth. If you have one of these devices at home, you can do your therapy session, get feedback right away about what you need to do next. So anyway, that's one
And
thing.
I would imagine that would have multiple applications as well as it gets developed. It's beautiful. Tell us about the gamma wave, the 40 hertz research. I was so thrilled to be able to get into the booth and experience it.
Yeah, so one of the most exciting things going on right now, and I think Grace is going to talk about this as well, is that people have suspected for a long time that particular frequencies have an effect on our being. Indian classical music, for instance, has whole theories of how different frequencies affect different parts of our body, different parts of our emotions and spiritual being. And there's starting to be real research to show that there are frequencies that do very, very specific things to our bodies and to our minds. Two of my colleagues at MIT, Li-Wei Tsai at the Picower Institute and Ed Boyden at the Media Lab and the McGovern Center, discovered that gamma frequencies, which are in the range of about 20 hertz to 50 hertz, but most effective around 40 hertz. That's the low E on the piano or the low E of the double bass, more or less. They were noticing that that frequency had a very powerful effect on mice first, and they started out with light. And it turns out we have microglial cells in our brains, and they're kind of like the vacuum cleaners in our brains. They activate the immune system for the brain, and they clean up dead neurons and other substances that we don't want in our brain. And it looks like the 40 hertz gamma frequency keeps these microglial cells healthy. And if the gamma disappears, the microglial cells don't do their work, and gook builds up in your brain, specifically plaque, which is one of the reasons, one of the things that causes Alzheimer's disease. And they found out with flashing lights at 40 hertz, the microglial cells got activated, the plaque disappeared from the brain, and they actually could restore clarity of mind to mice. And we started working with them to see if audio would work as well as light, and if...
So, and just to be clear, you're talking about 40 vibrations per second, whether it's a light flash or whether it's a sound vibration, right?
That's right.
That's what that means. Can we just hear it? Can we hear what the gamma frequency sounds like?
Yeah.
So we're listening to this and our brains are being cleaned up as we're listening. Is that right? That's the idea.
All of you can feel it right away. So,
Yeah.
no, actually, a lot of the research with audio has been done with exactly that signal. And of course, it's the 40 hertz, but it totally depends on what the spectrum is. And so a lot of work in our lab, I think Grace's lab too, has been to discover exactly what combination of frequencies. I kind of like that sound, but most people don't want to sit. You have to. Most research so far has been done with listening to either that sound with flashing lights, one or the other, for about an hour a day for a week. That's usually the way you measure what the effect is. I kind of like that, but most people don't. So what we've been doing is to figure out many other ways to deliver the gamma frequencies. It turns out that, I guess not too surprisingly, but if you combine the audio and the visual, so the flashing light and the audio, the effect on the brain, what you're trying to do is to kickstart the brain into creating these gamma frequencies on its own. Because in a normal brain, we have the gamma frequencies that seem to regulate the cleanup facilities, the immune facilities, and a lot of healthy aspects of brain behavior. We're only now discovering all the different kinds. But these gamma frequencies in the brain disappear, a lot of bad things happen, so you try to restart them. Alexandra made this instrument called the Gamma Moon, where, like the Labrasense, you move your finger on electrodes. The way you move your fingers creates a gamma light in the room, gamma sound, and also the whole thing pulsates, so you have gamma vibration. And so it's kind of like a mini, you can carry this thing anywhere and when you were at the Media Lab, you can turn any room into a gamma installation. And as we know, the research shows that if you participate actively in a musical activity, doing something, the effects are more powerful. So we're making instruments like that. And I've been working on taking the gamma frequencies and embedding it in pieces of music. So, is it possible to have a piece of music that takes you on a journey, that maybe helps you listen more carefully, that's something you want to listen to, and also has this therapeutic effect? So
I would love to hear, let's hear a little clip of this, and we have to go on to Grace. And also, I just want to say that next week, we're actually going to have your colleague with us, Dr. Li-Wei Tsai, and we'll learn a little bit more about this. But you actually made this much more beautiful, much more listenable. And I'm supposed to sing a soprano obbligato, a kind of a vocalese above it, to be premiered at UC Berkeley in April, pandemic permitting. But let's hear a little snippet of that. Thank you so much, Tod.
This is the Kronos Quartet who commissioned the piece, playing a little bit of the end of Gamified.
I love that. A concert and brain health combined. This is good. This is multitasking in the future. So Grace, welcome. You're also doing some research in gamma waves in collaboration with the Epilepsy Department at Dartmouth. So tell us about this work.
Certainly. I have a slide that I can show you that basically shows how, as a composer, I'm trying to develop ways to, as Tod mentioned, it was a really great way of explaining this. How can we embed this mechanism into the ways that we algorithmically control and work with music and sound? And so we produced a number of different kinds of stimuli that all tried different ways to embed this kind of therapeutic frequency into music. We played this music to persons with epilepsy who were undergoing intracranial monitoring. So they were actually being prepared for brain surgery. And so we had the chance to actually record from the surface and inside the brain what is happening when they are listening to these new kinds of musical signals. And what we found was that for the patients who were particularly prone to a high number of what we call IEDs, which are interictal electroform discharges, these tiny, tiny spikes that we see in their brain signal, being exposed to these specifically engineered musical samples actually reduced the number of those IEDs that they had in their brain rhythms. So as I was mentioning to you and Tod before the show started, we're actually trying to kind of backtrack a little bit. The whole gamma inspiration was originally started with this Alzheimer's research. But in epilepsy, there are a number of different mechanisms that we want to study. And so we're trying to look more broadly at how the brain can basically entrain to these kinds of musical rhythms that it's exposed to, and what kind of mechanism can we uncover that might produce these kinds of beneficial changes in the brain.
Was there a sound card embedded in that slide? Could we hear an example of it?
Sure. Sounds very similar to what Tod played, not nearly as beautiful though. In this particular sound, this is an example of how, one of these algorithms that we can use to generate this frequency. I'm actually working on an album of music right now. And for the brain-specific track, you'll hear things that are very similar to this. But the idea is that we can compose a composition that has some kind of healing intent to it, and how can we embed scientifically validated algorithms into how that sound was engineered.
Well, so you're both a performer and researcher. So Todd's a composer, you're also a composer. But tell us about how your research influences your performance and vice versa. Because you mentioned in our conversations that you see yourself as a music engineer.
Certainly. So I loved how Tod explained how the Hyperscore project kind of inspired all of these, new kinds of projects out of it. Hyperscore, actually, I remember reading about that when I first started college, and that project is pretty much why I'm doing music technology now. So I really loved hearing that story. But in a similar way, I think I actually started out doing this brain music performance after doing music neuroscience research as a student. And I was really captivated by this idea of being able to reveal something about what's going inside my experience as a performer on stage, and how music and sound can actually help to reveal that. As a Western classical music performer, I think I was very well trained to put on a mask that will impart what the composer was intending for me to communicate to the audience. And it was actually something very radically new and actually quite scary as a performer to go on stage and for everything happening internally to instantly be revealed to the audience, and to learn how to be expressive in that very internalized way.
It's a new layer of vulnerability that you add to your performance. I mean, I chapeau to you for having the courage to do that. So let's pull up your SoundCloud webpage, because anybody can go and sort of see a little bit more about your work.
Oh, sure. I think I actually have a slide here that just shows my Bandcamp, and this is, how I release music to the world. So if you would like to find out more about these tracks, you can visit that there.
Super, definitely. And are you the first person to perform brain music?
No, not at all. In fact, I prepared a slide for you of Alvin Lucier's work. In 1965, he gave this first performance of music for solo performer. Interestingly, I read that it was named as such because it was really designed as a piece for only he to perform and play. And if you look at this original video of this performance, you can see that he's developed what is actually a very detailed performance practice around how he opens and closes his eyelids to change the level of alpha activity that he's producing in his brain. You can see in this analog electronic diagram that he has a bandpass filter that is selecting for alpha activity and selectively sending that alpha activity through loudspeakers that are connected to percussion instruments. And so you're only hearing sound when he produces a lot of this alpha activity. Producing alpha activity on the spot.
Well, your work, so you're using your heartbeat and brain waves processed through a computer and playing your flute, you're playing the flute. So in harmony. So how did the brain waves and heartbeat get translated to music?
So that's a really good question. I actually prepared two different videos for you. The first one was one of the very first brain music performances that I ever did. This was at a venue called Red Star in Cambridge, which is right across the street from the Media Lab. This is a performance with Max Citron in 2015. And in that performance, the software that we used was designed just like Alvin Lucier's piece. It was really designed that we're going to be very meditative and zen on stage. We're going to be producing very strong alpha rhythms. And as I told Renee before, this exact video that maybe we'll get to see is a video of the first time that I experienced stage fright since I was maybe 14 years old. And I actually had to recalibrate the algorithm on stage while I was performing in order to kind of match this less zen state that I was experiencing there. And actually that experience influenced me to develop a whole nother kind of algorithm that instead of adapting a very traditional brain-computer interfacing paradigm where we are trying to estimate and classify what's going on in the brain, instead I switched to a different kind of algorithm where instead I'm basically converting the signals that I get into the computer more or less directly into sound. I like to call it a kind of spectral mashing, but I'm basically combining the spectrum of the brain rhythms, heart rhythms, skin conductance data that I get with my own flute and voice sound while I'm on stage.
It's really beautiful. So you also created the tones that get translated in the background too. It's incredibly cool. We're going to play a piece at the end of the broadcast today, so everybody can stay and hear it, because I just think it's another beautiful language. So what is the impact of music listening on breathing, heartbeats, brain responses? I mean, how can music and technology, I think you prompted this question actually, lead to greater empathy?
Right. So as Tod mentioned, with his work, this one artistic work kind of inspiring a lot of research out of that. My own performance work, after giving these performances, I noticed that audience members were approaching me and telling me these very crazy things about what they were experiencing when they were witnessing this. So what it was like for them to hear somebody's heartbeats on stage, what it was like to observe somebody translating their brain rhythms into sound. And so I actually became inspired to study scientifically what happens when somebody hears these kinds of sounds. And as a secondary question, I'm basically trying to test this theory that this kind of empathetic processing of sound might actually underlie a lot of how music affects us. To begin with. So even if we're not talking about these sonified brain rhythms, there must be something about the way that certain pieces of music move us, and part of that might be this kind of empathetic process.
Well, I know when I'm singing the fourth movement of Four Last Songs of Strauss, my breathing slows down. I mean, part is that I'm singing long phrases. It's a little bit like swimming, but part of it is the music. It's a very Zen experience. This is so fascinating. Listen, we're out of time. We need to go to a couple of questions. And I'm going to start with you, Adam, because they came in first. How has Dr. Gazzaley addressed and incorporated video game culture into the therapeutic games you've created? And that's Christopher. Another Christopher says, do listening to music and playing video games stimulate the same parts of the brain? So two questions.
Yeah, great questions. You know, the culture of video games is a complex one. There are so many different types of games, and they each have their own unique cultures, whether it's like massive role-playing games and strategy games and sort of sandbox games like Minecraft, where you create, now Fortnite. So it's, you know, I wouldn't say that we've tried to capture any of those particular cultures in the games that we created. And if anything, I think that a therapeutic video game, one that's designed to entertain but also help your mind in this way, will develop its own type of culture. So it's something that I'm sort of excited to see where it evolves, especially over the next year once it starts getting into all these children's hands. And in terms of areas of the brain that are active, you know, music is a big part of many video games, including our video game. We had a composer, devoted to making unique score for our video game. And so it's hard to separate out the video game from music effects on the brain, because there's a lot of audio information in all of video games. But, there is some commonalities in terms of engagement and flow state that people will talk about in both music experiences, even listening experiences, not just playing experiences, and the flow state of being engaged in a video game where you lose track of time and just, enter a hyper sort of attentive state. And so there are a lot of similarities between music and video games, besides the fact that they often go together.
William wants to know, how does Dr. Gazzaley's game apply to adults with ADHD? Does it improve on one's memory issues or executive function issues, which many ADHDers need to focus on?
Yeah, so we have studies in multiple populations with our game, including adults with and without ADHD, seniors, studies in depression, multiple sclerosis, and we see these types of attention benefits broadly. And they act on other areas of executive function that's being referred to in the question, like working memory. We often see benefits of that. Also autism, I forgot to mention. So just to summarize, the bottom line is that our attention abilities are fragmented in so many different conditions. I would say it's hard to even name a neurological or psychiatric condition that doesn't have attention issues as part of it. It's just how our brains work. These are large dynamic network processes, and they're very vulnerable to anything that affects your brain. And that's why I got really excited about building a video game treatment that works on attention, because it could have the most benefit across so many different populations. Maybe just to close up this point, the music game that we created is also about attention, right? It's engaging in attentional ways with the rhythms, both how you hear and see them and how you move to them. But we have many other games that also act on different aspects of rhythm. So for example, we have a meditation inspired game called MetaTrain, where there is no music, there's no visual information, your eyes are closed, unlike most video games, and you focus on your breath and you get feedback and you work through longer and longer periods of time of sole attention to your breath. And that also improves different aspects of attention. So I think there's a lot of exciting areas in front of us to explore how we can use technology and music, video games to help improve how we pay attention. And then because attention is so fundamental, just getting to a point that Grace was talking about, we hope to see its impact on other things like stress and anxiety, which are just, mood disorders, which are just overpowering people, especially with the pandemic now. So that's a little bit of my vision of how these all come together.
Yeah, we'd like that to be fast forwarded. We need this now.
I'm working as fast as I can.
I know. Pamela asked, PTSD and Alzheimer's, are they on the list?
Yeah, they are on the list. We have a PTSD study that's completed now at the VA hospital that will be putting that data together. And then Alzheimer's, where we're working, is a population of individuals. Many of them have this designation. It's called MCI, mild cognitive impairment. And it's that state in between aging, healthy aging, and in between dementia, where we're concerned, but there's still high levels of function. We think that's a really important stage in someone's path towards Alzheimer's or dementia, where we can have great impact. And we are starting studies there this year.
Super. Todd, Jessica wants to know, she says, I have cerebral palsy as well. And this series has sparked my interest in being studied or in participating in an experiment of some sort to understand the relationship between my condition and how it affects my ability to make music. I'm also a singer. Is there a way I could do that?
Yeah, where are you? Are you near Boston? That would make it really easier.
There you go, Jessica. Maybe she'll respond again.
But
there's another question for you. Molly asked Todd, how much do the effects of gamma frequencies vary from individual to individual?
So far, it looks like the effect is pretty strong, and it doesn't seem to vary so much from individual to individual. The rigorous tests, as I mentioned before, were, you sit in front of in a gamma experience for an hour for about one day for a whole week, and so most people seem to have the same effect, that your brain kicks in and starts making the gamma frequency almost immediately. It's actually really interesting when the experiment comes on and all of a sudden the lights flash or the audio comes on, the brain almost immediately entrains and shows the gamma signal. Unfortunately, when the light or the audio stops, the gamma signal in your brain doesn't linger very long, and it stops pretty quickly as well. So one of the questions now is, how can we make experiences where you don't have to sit in a special gamma flashing room all day? How can you do something where the effect lasts longer, where the creation of the gamma in your brain continues, But as I say, the good news is that it seems to work for most people pretty well. So
You said one family had even created a booth in their home
yeah,
because, yeah, exactly, as a treatment in a way. So we had one, let's see, Rosalva wanted to know if remembering gamma wave sound prolongs the effect and the benefits would give new meaning to the term earworm. And Trevor asked about using this in public schools. Does the quality of sound equipment impact the fidelity of the positive gamma effects?
I see.
Oh,
So
Jessica's in Texas, by the way. She's in Frisco.
okay, but I'd be happy to be in touch with Jessica about how we might be able to send her some things she could try, and I'd like that a lot.
Let us know on Facebook, Jessica, how to reach you.
That'd be great.
I love that you're a singer too. You know what? Well, let's take these questions next week because I'll actually be revisiting this next week. And I'm so grateful to you all for your time. Thank you to our extraordinary guests, Dr. Adam Gazzaley, Tod Machover, and Dr. Grace Leslie. We look forward to seeing you all again next week. And for a reminder, do sign up for the newsletter at my Facebook page or my website, reneefleming.com. And before next week on Saturday night, for the first time since March, I will be stepping back onto a stage with a live audience in the room. I'll be performing a special concert with my friend Vanessa Williams on stage at the Kennedy Center Opera House for a small socially distanced audience, but you can watch live via live stream from your own home. It's called A Time to Sing. You can find the details at the Kennedy Center website, and I'll also, of course, post them on Facebook. It's only $15, and when you purchase, you've got it on demand through the end of the year. It won't just be my first time back with an audience, but a first live performance on a Kennedy Center stage in 6 months. So I hope you'll support our National Cultural Center and watch. And so next week on Music and Mind Live, we'll look at music and treatment for the most common cause of dementia for older adults, Alzheimer's disease. It's estimated that 50 million people around the world are living with Alzheimer's and other forms of dementia. And I'm glad to say that we'll revisit our 40 Hertz research with fantastic experts joining us. Dr. Li Wei Tsai is professor of neuroscience and director of the Picower Institute for Learning and Memory at MIT. She's also the lead investigator of MIT's Aging Brain Initiative and has done groundbreaking research on gamma wave treatments for Alzheimer's. And Dr. Concetta Tomino is the executive director of the Institute for Music and Neurologic Function, which she co-founded with world-famous author and neurologist Dr. Oliver Sacks. Dr. Tomino is renowned for 4 decades of research and clinical applications of music and neurologic rehabilitation. And I also met her through Mickey Hart, and also Adam. And we'll welcome a dedicated advocate for Alzheimer's research, singer-songwriter Chris Mann. He's topped the Billboard and iTunes charts and reached 37 million viewers with his 2012 performance on NBC's The Voice. He's spoken at TEDx Talks with Dr. Rudy Tanzi, who I've also welcomed on the show, about his family's reconnection to Alzheimer's disease and their song, Remember Me, written to raise money for Alzheimer's research. It's such a beautiful, moving song. So many people have a family member or friend affected by this condition. So I hope you'll all join me for this episode. So we're going to end today with these clips from Grace Leslie's performance piece, Vessels. And Grace, would you please introduce both clips for us, and then we'll show them. And thank you so much. We'll see you next week.
Certainly.
Go ahead, tell us about.
Oh, sure. So there's one short clip at the beginning, and this is that you'll get to see me experiencing stage fright here. And then the second clip that you'll see is the performance practice that resulted out of this changed algorithm. So you'll hear what it sounds like more or less for my brainwaves and heartbeat to be converted directly into music, and me learning how to work with that expressively on stage.
Wow. Young singers everywhere, you need to figure out how to change algorithms during your performance. I'll leave that for my next life.